Hello! Today we wanted to show you a trace of the Windows OS while it's booting in UEFI mode. Our goal here is to show you, well, first that this kind of thing is possible at all in REVEN, and second, to illustrate the kind of details you can get from a trace like this. Okay, so this is what we recorded. It starts while the VM is still running the firmware before anything is loaded. Note that since we're executing the open source OVMF firmware, we're able to get the symbols, so we would be able to see what EFI services the boot process is going to use. The first binary that's going to start is called bootmanager.efi. This is a PE binary, that's where the actual boot process starts. This binary is going to load another one called winload. This one is going to set everything up so that the kernel can finally take over, in our case, at about 3 billion instructions from the start of the recording. As usual, this trace contains a lot of information, so let's focus on a few tidbits that might be hard to see otherwise. One of the first questions we might ask is, where and how early are there disk accesses? Especially disk writes, because these will of course alter the state of the machine at a moment where they're hard to detect. So if we look inside the first binary, bootmgr, for calls to file write, yes, there are. Let's dig into that. What are they actually writing? If we look at the arguments stored in R6, this is the file number we're writing to, and all of these calls are going to write in file number 4. If we want to see which file this is, we can look for calls to file open. Here, the file number will be stored at the location passed in R9. So if we look there and use the memory history to see what we're going to write, this call to file open is actually opening file number 4. Going back to the start of the call, the file we're actually opening is stored in RDX and is called bootstat. So we learned that bootmanager.efi actually writes to a file called bootstat. If we look for accesses in winload, there are some as well. Another similar type of search might be to look for calls to load image instead, to see the binaries we're loading. Here, the binary is stored in R8, and we could see we are opening the actual kernel, and we could do the same for all load image call. Another and very different point of interest might be seeing the setup of the GDT, the global descriptor table, which describes the segmentation, the content of the CS, SS register, etc. for the kernel to use. So going back to the start of the kernel, like so, and dereferencing the register called GDT base, here we're interested in seeing the CS register, which is in the entry 10 right there. Using the memory history, we can see who actually wrote it. We're inside a method called arch set GDT entry inside the winload binary. Finally, and in a similar fashion, we can try and see which code sets up the arguments for the kernel. So going back, the first argument to the kernel is load parameter block structure passed as first argument in RCX. For instance, here we might be interested in seeing the call driver list, which is at offset 50, and by accessing the first item, we can see it contains a string describing the driver name. And looking at who wrote this string, using the memory history, we end up in a piece of code called by OSL-find driver, which sounds like it's building the list of driver from registry entries. And that's it for this video. If you found this content as interesting as we do and want to know more about it or REVEN in general, don't hesitate to contact us via the website or contact@tetrain.com.